I want you to close your eyes for a second. Go with me here. Transport yourself back to, say, 1993. You're sitting in front of a big beige tower PC. It's heavy, it's loud, and you've just hit that power button.
Oh, I know that feeling. The whir of the fans. That almost jet engine sound.
Exactly. And then you get that really satisfying mechanical clunk grind clunk from the faulty
Like
hub.
checking for a disk. Yep. That sound is just burned into my brain. It's the sound of anticipation.
It is. And then the screen glows. You get that blinking underscore, and suddenly text starts scrolling really fast.
Lines and lines of it.
Yeah. Stuff about drivers, memory managers, buffers, all these weird acronyms. It's like watching the machine's heartbeat as it wakes up. And today, we're going to talk about the thing that actually controlled that heartbeat.
We are talking about the gatekeeper, the absolute master of the PC experience for decades, the one and only CONFIG.SYS.
CONFIG.SYS. You know, just saying the name brings back this mix of nostalgia and, well, a little bit of anxiety.
Anxiety is the right word. I mean, for a long time, that one little text file was the only thing standing between you and a computer that was, well, a useless brick.
So, okay, here's our mission for today's deep dive. We are going to unpack this ASCII text file. We're going to look at how it worked, why it was so critical, and honestly, the surprising amount of, like, drama and technical warfare that was hidden inside those simple lines of text.
It's a really fascinating story. You're moving from a world where you had to manually tell the computer how to think,
right, to
the kind of black box systems we have today where, you know, everything is hidden away from us.
Let's start with the absolute basics. What is config.sys? Because for my teenage self, it was just this magic scroll I was told never ever to touch.
Well, at its simplest, it's a configuration file for DOS and for OS/2, and it's a user-maintained ASCII text file.
Which means it's human-readable. You could just open it up.
Exactly. You could open it in Notepad or the old DOS editor. It wasn't some weird binary file.
And it had to be in the root directory, right? cconfig.sys.
It had to be, right there in the root of whatever drive you're booting from, and its job was to specify startup options that you cannot change after the system boots. That's the key.
Oh, okay.
Once the operating system is fully up and running, config.ys has done its job. It's finished.
So it's like the setup crew for a concert.
That's a great way to put it. It controls memory management. It loads all the low-level drivers for your peripherals.
Like your CD-ROM or your sound card?
Precisely. And it sets up the whole environment for the applications that are about to run.
Now, I found this little nugget in the source material totally wild. I always just assumed config.ys was born with MS-DOS. You know, that Bill Gates sketched it out on a napkin or something. But that's not true, is it?
Not even close. The source points out that the name and the whole concept really came from an operating system called DX85M.
DX85M? I have never, ever heard of that.
Most people haven't. It was for the Durango F85 computer, and it came out in 1978.
1978. So the DNA of this file is, what, 5 years older than DOS 2.0?
It is. The whole idea of having a simple text file to configure your hardware, I mean, that was revolutionary. Before that, you might have to recompile a kernel or, you know, literally flip physical dip switches on the motherboard.
Okay, so let's walk through the boot sequence. I think this is where people get confused about the order of operations. I hit the power button, the BIOS does its thing, then what?
So the BIOS hands off control to the DOS system files, usually IOSYS. And the very first thing that file does is look for config.sys.
Before anything else. Before you see a command prompt.
Way before. It reads config.sys to figure out the rules of the road. You know, how much memory do I have access to? How am I supposed to talk to this hard drive? Is there a mouse connected? It processes directives, which are settings, and load commands, which are the drivers.
And only after it's finished with all of that.
Only then does it finally load the command shell, which is usually command.com. And then at the very end of that process, the shell runs autoexes.bat.
Okay, let's pause right there. Because config.sys and autoexec.vat, they're like the dynamic duo, Batman and Robin. But they do totally different things.
They do, and it's a critical distinction.
So how do you explain the difference?
Think of it like this. Config.sys is building a house. It's the construction crew. It decides the structural laws. This room is for memory. This pipe connects to the sound card. We have this many shelves for files. It's setting up the physical environment. The infrastructure.
The blueprint and the build. Okay.
Precisely. Autoexec.bat is you walking into that finished house, turning on the lights, starting the coffee maker, and running your morning routine. It runs programs. It sets your path. It starts your menu.
That makes so much sense. So if config.sys is wrong, The house might not even have a front door.
Exactly. If config.sys fails, the operating system doesn't know how to be an operating system. If autoexe.bat fails, you just didn't launch your favorite game automatically. It's a much smaller problem.
I love that analogy. Okay, let's get into the magic spells, the directives themselves. Because reading the source material, it's like a spell book. You had to know the exact incantation, device, something.
Device was the big one. I mean, this is what extended the system's capabilities. The BIOS knows how to talk to a floppy drive and a keyboard. It has no idea what a CD-ROM is.
Or a scanner or a fancy sound card.
None of it. So you have to literally say device CD-ROM.sys or device SB16.sys. You are manually patching the operating system every single time you boot, telling it, hey, look over here, I have this new piece of hardware.
And one of the most common drivers the source mentions is anti-SYS.
Ah, anti-SYS. That was for the display. It gave you colored text, cursor movement, all that good stuff in the DOS prompt. If you wanted your BBS or your menu system to look cool, you needed anti-SYS.
Then there were the memory ones. The source highlights anti-SYS, and this just unlocks a core memory of pure frustration for me.
The memory battleground. The infamous 640 kilobyte barrier. See, the original Intel architecture could address 1 megabyte of memory, but DOS reserved that top 384K for hardware, so that left only 640K for you, the user.
Which was fine in 1981, maybe, but not in 1993 when you're trying to run a game.
Exactly. Games got bigger, spreadsheets got bigger. So HiMemSys was the driver that managed extended memory, all the RAM that lived above that 1 megabyte mark.
And that led to the famous command, DOS high UMB.
That was the absolute game changer. DOS high told the system to load the operating system code itself into the high memory area, a tiny little slice of memory just above that 1 memory line.
And by doing that, you freed up precious conventional memory down below.
You did. And UMB, that stood for upper memory blocks.
Right.
That let you cram your drivers into that reserved upper area, too. You were constantly shuffling things around.
It was like a game of Tetris with your RAM, just to get, what, 600K free so Doom would actually launch?
It absolutely was.
Okay, 2 other directives here that I know I typed 1,000 times but never really got. Files and buffers.
Files 30. It was just standard advice, right?
Yes. But why? What was I doing?
It's actually quite literal. It tells the operating system how many file handles, which are basically just slots for open files, it should reserve. How many files can be opened at the same time, system-wide.
So if a program tried to open a 31st file and you'd only set it to 30?
The program would crash. It would just give up.
So why not just set it to files 1000 and be done with it?
Because every single file handle you reserve takes up a tiny bit of that precious conventional RAM. And remember, we are fighting for every last byte.
Oh, of course.
If you allocate memory for 100 files, but you only ever use 20, you're wasting resources. You are the systems administrator of your own desktop, manually balancing the budget of your own memory.
That is a level of responsibility we just do not have today. I don't think I ever worried about file handles on my phone.
And you shouldn't have to. But back then, you had to know.
There's one more directive here that leads us perfectly into the panic mode section. Shell.
Yes. The shell directive tells the system where to find its command interpreter. By default, that's command.com.
Okay. But what happened if config.SYS was broken? Or if that shell command pointed to a file that didn't exist?
Well, if the file's just missing or corrupt, the system can still boot. It just uses default settings, which are usually terrible. But if the shell is missing, that's a full-blown crisis.
The dreaded message. Bad or missing command interpreter.
It still sends a chill down my spine. In versions of DOS before 6.0, if the system couldn't find the shell you told it to find, or the default one, it just stopped.
Halted. Dead in the water.
That's it. Just a blinking cursor and a complete refusal to do anything else. But the source notes a really important evolution and safety here. By MS-DOS 6.0 and Novell-DOS 7, they added a failsafe.
A failsafe.
Yeah, if it couldn't find the shell, it would actually prompt you. It would ask you to manually type in the path.
So it's like saying, hey, I can't find this front door. Can you show me where it is? Instead of just burning the house down.
Exactly. And speaking of safety, we have to talk about the bypass features. The F keys.
F5 and F8, oh, these were absolute lifesavers.
They really were. F5 was the skip mode. It just ignored config.SYS and autoexe.bat entirely, gave you a clean boot.
And F8 was the trace mode.
F8 was the single most powerful tool a user had. It let you step through the file line by line. It would ask you, load this driver, yes. Load this one, yes. Load this one, no.
I remember doing that.
Yeah.
It was how you found the one line that was crashing your computer. Okay, the mouse driver is fine. The CD-ROM is fine. Oh, wait, it's the scanner driver. That's the one that crashed it.
It turned debugging into a simple process of elimination. It empowered you to fix your own system.
Now, this is where it gets really, really interesting for me. I always thought config.SYS was just
Yes.
config.SYS. But the source material dives into this OS war between MS-DOS and DOC-DOS.
Yes.
And apparently, their whole approach to this file revealed their entire philosophy.
This is one of the most technical but also fascinating parts of the source, because on the surface, the files looked pretty much the same. But under the hood, MS-DOS and Docker-DOS processed them in completely different ways.
Okay, let's start with MS-DOS, the Goliath in this story. How did it handle the file?
MS-DOS used a compilation method. When it read config.sys, it would basically compile the whole thing into a tokenized, in-memory representation before it actually executed any of it.
Tokenized. Break that down for us.
It means it converted the text into a more compact, machine-readable code in memory. It was an optimization. But because it did this all at once, there was a hard file size limit. I think in later versions, it was up to 64 kilobytes.
Which is a lot of text, to be fair. But it had a side effect on the order of things, didn't it?
It did. Because it compiled at first, MS-DOS felt it had the right to reorganize your directives. For instance, it would always force device drivers to load before TSRs terminate and stay resident programs, no matter where you actually put them in the file.
So MS-DOS was basically saying, I see what you wrote, but I know better, so I'm going to do it my way.
Pretty much. It was rigid. Now compare that to Docker-DOS.
The underdog, what did they do?
Docker-DOS was an interpreter. It read the file line by line, and it executed it line by line.
So if I put a command at the top of the file, it ran first. If I put it at the bottom, it ran last. Simple as that.
You had absolute control. If you had some weird conflict where one driver needed to load before another one, Docker-DOS just let you solve it by rearranging the lines. MS-DOS might have just rearranged them back behind your back.
And the source says this line-by-line approach meant DR-DOS had, what, unlimited file size?
Theoretically, yes. Since it didn't have to hold the whole compiled file in memory at once, you could have a gigantic configuration. But Docker-DOS didn't just stop there. The source lists these advanced features that make MS-DOS look, well, kind of primitive in comparison.
Oh, yeah.
Docker-DOS effectively turned config.sys into a programming script. It introduced logic, flow control.
Logic in a config file. Give me an example.
Okay, look at the chain command. This let you hand off processing to a completely different file. You could modularize your configuration, or the SWSH and goTo commands.
Go-to, like in basic programming.
Exactly like in BASIC. You could jump to different labels inside the file based on what the user did.
Wait, user input. You're telling me the computer could talk to me during the boot process?
Yes, the dot directive. In Docker-DOS, you could write a line like device sound.sys. During the boot, it would pause and literally ask you on screen, do you want to load sound.sys? Yes or no?
That is incredible. I remember having to make different boot disks like physical floppies because my setup for Wing Commander was different from my setup for Microsoft Word. And you're telling me DR-DOS could have just asked me?
It could have just asked you. And not only that, you could build a full menu system. Using the get key command, it could wait for you to press 1 for your game setup, or 2 for your work setup. Docker-DOS even had color and beep directives.
I could make the boot menu blue.
You could make it blue, you could make it beep when it was ready for input, you could have nested menus. It treated the user as an active participant in the boot process, not just a spectator.
That sounds so much more modern. It feels like a precursor to the JRB boot manager we have in Linux today.
Yeah.
So we have this really sophisticated system in DR-DOS and the solid, if kind of rigid, system in MS-DOS. What happened?
Yeah.
Why aren't we editing config.mors files today?
The evolution of Windows happened. As Windows technology started to really diverge from its DOS roots, the reliance on config.sys just diminished.
The source mentions the Windows 9X era, so Windows 95, Windows 98. They still had the file though, right?
They did, but it was mostly for backward compatibility. Windows was starting to take over the job of driver management with its own 32-bit drivers, which, didn't live in a 16-bit text file.
And there was that weird renaming game. The source mentions config.dos.
Oh, yeah. If you were dual booting, say you had Windows 95, but you wanted to go back to real DOS, 6.22 sometimes, Windows would play this shell game with the file names. When you booted into DOS, it would swap the name, so config.dos became config.os again.
And then came the end of the line, Windows Me.
Windows Millennium Edition, and the source is very, very clear on this.
Yeah.
Windows Me does not use config.sys at all.
It's just gone.
Completely ignored. You could put commands in there. Windows Me just glosses right over them. Instead, it loads all those environment variables directly from the Windows registry.
Right.
Specifically from a place called HKLM System Current Control Session Manager environment.
That's a mouthful. And it is definitely not a simple text file sitting in your root directory.
Not at all. And that really marks the transition. We went from a file you could open with Notepad to this huge binary database hidden deep inside the system that you can only get to with a special editor.
But wait, the source says there's one survivor from this era.
Yes, OS2.
The operating system that could have been king.
OS2 and its modern derivatives, like ArcoOS, they still rely very heavily on CONFIG.SYS. Because of the way OS2 is architected, it uses that file to configure the whole environment before the graphical part even loads. So for a small, dedicated group of users, config.SYS is still very much alive.
You know, that makes me happy somehow. It's like finding a living dinosaur on a remote island.
It is. It's a testament to a very specific era of computing design.
So let's zoom out. What does this all mean? When we look back at this file, config.SYS, what are we really looking at?
I think we're looking at an era of transparency. This single file represents a time when users were, yes, forced, but also empowered to manage their computer's resources themselves, manually. You had to know what a buffer was. You had to know where your memory was going.
It was a burden, for sure, but it was also, I don't know, educational.
Absolutely. It demystified the machine. When you edit a text file to make your sound card work, you understand fundamentally that the sound card is just a piece of hardware waiting for a piece of software to talk to it. Today, you plug in a USB device, it makes a little sound, and it just works, which is convenient, but it hides the reality of what's actually happening.
It's the black box effect. We don't know how it works, so we have no idea how to fix it when it breaks.
And when you look at those DR-DOS features, the scripting, the logic, it shows that config.SYS wasn't just a settings list. It was becoming a programming environment for the boot process itself. We were literally programming our computer's wake-up routine.
That brings us to the so what of this whole deep dive. We traded that control for convenience. We traded the ability to step through a simple text file line by line for a registry that is massive, complex, and honestly, pretty opaque to the average person.
It's the difference between driving a car with a manual transmission, where you feel every single gear change, and riding in a self-driving car. I mean, the self-driving car is safer, it's easier, it's arguably better for most people, but you lose that connection to the road.
Before we wrap up, I want to leave our listeners with one last provocative thought based on that very transition. The move to the registry in Windows Me.
Go on.
We tend to assume that newer is always better, that moving all those settings into the registry was an upgrade.
But was it?
Did we really gain stability by hiding these settings away? Or did we actually lose a valuable layer of transparency and control? When your computer's nervous system was just a text file you could edit yourself, you own the problems, sure, but you also own the solutions. Now, when the registry breaks, you're often just told to wipe the drive and reinstall Windows.
That is a provocative thought. Is obscurity really security? Or is it just a loss of agency?
Something to think about the next time you're staring at a loading screen. Thanks for diving deep with us today into the hidden world of config.SYS.
My pleasure. It was great to revisit the root directory.
See you on the next deep dive.